Have you ever wondered why anything exists at all? This is a question that has puzzled scientists, philosophers, and thinkers throughout history. The enigma of existence is a daunting mystery, one that challenges our very understanding of reality. Consider this: why is there something instead of nothing? It's a simple question, yet it opens a vast cosmos of contemplation. Some theories suggest the reason for existence lies in quantum fluctuations, tiny changes in energy that could have sparked the birth of our universe. Others propose the multiverse theory, positing that our universe is just one among an infinite number of universes, each with its own set of physical laws. Yet, despite these fascinating theories, the question of why anything exists at all remains largely unanswered. The more we delve into this mystery, the more complex it becomes, stretching the limits of our understanding. A definitive answer to this question remains elusive, and it continues to baffle scientists and philosophers alike. What is the elusive dark matter that supposedly makes up 85% of the universe's mass? This question has puzzled scientists for decades. Dark matter, unlike the ordinary matter that makes up our bodies, the Earth, and the stars, is invisible. It doesn't interact with light or any other type of electromagnetic radiation, making it extremely difficult to detect. Yet we know it's there. The concept of dark matter was born when scientists noticed something odd about the way galaxies spin. They were spinning so fast that, based on the gravitational pull of their visible matter alone, they should have torn themselves apart, but they didn't. Something unseen was holding them together. This invisible substance exerting gravitational effects was dubbed dark matter. Despite our best efforts and most sophisticated tools, we're still grappling with the nature of dark matter. We've proposed numerous theories, from weakly interacting massive particles, WIMPs, to axions, yet none have been definitively proven. The Large Hadron Collider, the world's largest and most powerful particle accelerator, has been hunting for clues without success. So, what's next? Researchers continue to devise new methods to detect this elusive substance, hoping to unravel its mysteries. As we push the boundaries of our knowledge and technology, we inch closer to understanding this cosmic enigma. As we delve deeper into the cosmos, the mystery of dark matter continues to baffle us. What is causing the universe to expand at an accelerating rate? Let's journey back to the late 90s when scientists made a startling discovery. They found that the universe wasn't just expanding, but doing so at an accelerating rate. This was a shock, as it was expected that the pull of gravity would slow this expansion down. But something was pushing back against gravity, something mysterious and unseen. They called it dark energy. Dark energy is thought to make up around 70% of the universe, yet we know very little about it. It is not something we can see or touch. It does not emit light or energy, so how do we know it's there? We see its effects. Like a ghost in the machine, we see the universe expanding faster and faster, and we know something must be causing it. In the world of physics, understanding dark energy is a challenge of colossal proportions. It's like knowing there's a missing piece in the jigsaw puzzle, but having no idea what it looks like or where it fits. Theories abound, from the possibility that dark energy is a property of space itself, to more exotic ideas suggesting new dimensions or changes to gravity on cosmic scales. Yet despite our best efforts to unravel this cosmic conundrum, the enigma of dark energy remains one of the most perplexing questions in the cosmos. What is consciousness and how does it arise? Diving into the riddle of consciousness, we come across a profound question that has puzzled scientists and philosophers alike for centuries. What exactly is this thing we call consciousness? Is it merely the result of complex computations in the brain, or is there something more to it? Some theories propose that consciousness arises from the intricate network of neurons firing in our brains. This idea, known as the complex computation theory, suggests that consciousness is an emergent property of these neural networks, much like a colony of ants creates complex behavior from the simple actions of individual ants. Then there are those who propose that consciousness is linked to the mysterious world of quantum mechanics. They speculate that quantum processes occurring within the brain's neurons could give rise to consciousness. However, this quantum consciousness theory is highly controversial and lacks empirical evidence. What about the theory that consciousness is a fundamental aspect of the universe, much like space and time? Some theorists propose that everything, even inanimate matter, possesses a degree of consciousness. This idea, known as panpsychism, is an intriguing yet radical perspective. Despite these varied theories, we are still far from a definitive answer. The puzzle of consciousness, the sense of self-awareness and subjective experience, remains a deep enigma. It's like trying to explain color to a blind person, or music to someone who is deaf. The puzzle of consciousness continues to be one of the most profound mysteries that science has yet to solve. What is time and why does it only move forward? An age-old question that continues to baffle the sharpest minds in science. Time, as we perceive it, is a progression of events from the past through the present to the future. But why is this so? Why doesn't time move backwards, or sideways for that matter? Well, it all comes down to a concept known as entropy, the measure of disorder in a system. According to the second law of thermodynamics, in an isolated system, entropy always increases with time. Imagine a sandcastle on the beach. As time progresses, the once beautifully structured sandcastle will inevitably decay into a disordered pile of sand. You never see a disordered pile of sand spontaneously forming into a sandcastle, do you? This increase in entropy gives us a direction, the arrow of time, always pointing from order to disorder, from past to future. But here's where things get a bit tricky. In the microscopic world of quantum physics, time appears to be symmetric, meaning it could as well run backwards. Yet in our day-to-day life, we never experience this. This conundrum, known as the arrow of time problem, remains one of the greatest unsolved mysteries in physics. So, while we may live our lives by the ticking of the clock, the true nature of time remains elusive. The arrow of time remains a compelling mystery pointing us towards the future. Why does the quantum world behave so differently from the macroscopic world we live in? Let's delve into that question. Quantum mechanics is the branch of physics dealing with the smallest particles in the universe, like atoms and subatomic particles. It's a realm where things get really weird. Take superposition, for example. It's a concept where a quantum particle can exist in multiple states simultaneously. Imagine being in several places at the same time. Sounds odd, doesn't it? But that's what happens in the quantum world. And then, there's quantum entanglement. Two particles become entwined in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. It's like having two dice, miles apart, and whenever you roll one, the other always lands on the same number. Einstein famously called it spooky action at a distance. But why don't we see these phenomena in our everyday world? Why don't we see cats both alive and dead, or feel the effects of quantum entanglement in our daily lives? That's the dilemma. The transition from the quantum world to the macroscopic world we experience is not well understood. It's a boundary shrouded in mystery, a chasm that science is still trying to bridge. The quantum world continues to challenge our understanding of reality. The more we learn, the more questions arise. But isn't that the beauty of science? How did life originate on Earth, and is there life elsewhere in the universe? This question is like a locked box, hiding a myriad of secrets, a puzzle that scientists have been trying to crack for centuries. There are several theories about the origin of life on Earth. One popular theory is that of abiogenesis, which posits that life arose spontaneously from non-living matter, like simple organic compounds, around 4 billion years ago. Another theory is panspermia, the idea that life might have been delivered to Earth from another planet or even another solar system, hitching a ride on a comet or asteroid. But these theories, as compelling as they might be, are still just theories, waiting for that elusive, conclusive proof. While we grapple with understanding how life began on our own planet, we also gaze out into the cosmos, wondering if we are alone. The search for extraterrestrial life has been a significant part of space exploration. We look for planets with conditions similar to Earth, the so-called Goldilocks zone, where liquid water might exist. We listen for signals from distant stars and galaxies, hoping to catch a hint of an alien hello. But despite our best efforts and all the technological advancements, we have yet to find definitive proof of life beyond Earth. The universe, it seems, is exceptionally good at keeping its secrets. The question of life's origin and its possible existence elsewhere remains one of the greatest mysteries in science. Do we have free will, or is everything predetermined? A question that has been pondered by philosophers, scientists, and thinkers alike for centuries. The answer lies somewhere between the realms of determinism and free will, and it's a debate that continues to baffle us today. Determinism posits that every event, including human cognition and behavior, decision and action, is causally determined by an unbroken chain of prior occurrences. If this is true, then the concept of free will is an illusion. We are essentially complex biochemical machines, our actions and choices merely the results of a series of chemical reactions in our brains. On the flip side, free will argues that we are indeed the authors of our own actions. We have the ability to make choices that are genuinely free from physical determinism. So, where does quantum mechanics fit into this debate? Quantum theory, with its inherent uncertainty, may offer a way out of the deterministic world. It suggests that at the smallest scales of nature, events do not have definite outcomes until they are observed. This could imply that the future is not set in stone and leaves space for free will to exist. The paradox of free will is a mind-bending topic that leaves us questioning our very nature and the fabric of reality itself. It's a debate that intertwines science, philosophy, and our perception of reality. The question of free will continues to spark intense debate among scientists and philosophers. Why are the physical constants of the universe so finely tuned to allow life? The universe is a grand symphony, a masterpiece of precision. Every note, every beat, every pause is meticulously arranged to produce a harmonious melody that allows life to thrive. These are not just poetic metaphors, but scientific realities. The universe's physical constants, the speed of light, the strength of gravity, the charge of an electron, are all delicately balanced, so finely tuned that even the smallest deviation could render the universe lifeless. This fine-tuning is so precise that it's led to some fascinating theories. One of them is the anthropic principle. The idea that the universe is the way it is because if it were any different, we wouldn't be here to observe it. It suggests that our existence is not an accident but a requirement for the universe to be observed. Then there's the multiverse theory, which proposes that our universe is just one of many, possibly an infinite number, each with its own set of physical constants. In this cosmic lottery, it's no surprise that we find ourselves in a universe where conditions are just right for life. Yet, despite these theories, we're still grappling with the question, still trying to comprehend the intricacies of our cosmic home. The fine-tuning of the universe is a puzzle that's yet to be solved, a profound mystery that continues to challenge our understanding of existence. The fine-tuning of the universe continues to be a profound mystery. What happens after we die? This question has been at the forefront of human curiosity for millennia, an enigma entwining science, philosophy, and culture. It's a subject that transcends the boundaries of empirical understanding, making it a matter of personal belief. From a purely scientific perspective, death is the cessation of all bodily functions, including the brain's activity. It's the ultimate end of the physical self. However, it is not the physicality of death that stirs up intrigue, but rather the implications for what might lie beyond. Philosophically, death has been contemplated as the gateway to either oblivion or a new realm of existence. Some think of it as the final sleep, a state of eternal unconsciousness, while others consider it a transition, a stepping stone to another phase of existence. Culturally, the concept of death and the afterlife varies enormously across the globe. Some traditions believe in reincarnation, the soul's cyclic journey from one life to another. Others hold a belief in an eternal heavenly or hellish afterlife based on one's earthly deeds. And then there are those who believe in ancestral spirits, spiritual realms, and other metaphysical entities. The question of what happens after death, however, remains beyond the scope of empirical science. We can study the biological process of dying, but the aftermath, the beyond, is not something we can objectively investigate or measure. Death is a one-way journey with no return ticket, at least as far as our current understanding goes. Despite the advancements in neuroscience and consciousness studies, the concept of the soul or consciousness surviving death remains a hypothesis, a philosophical speculation. It's a realm where science, at least for now, has to step back, allowing room for personal beliefs, faith, and individual interpretations. In the end, the mystery of death continues to be the most profound and personal question that we all face. It's a question that brings us face to face with our mortality, with the fragility and impermanence of life. It reminds us of the enigma that is existence itself, the unfathomable mystery that we are a part of. As we journey together through these profound mysteries of existence, we understand that knowledge is not just about uncovering answers, but also about fostering curiosity, sparking dialogue, and building a community of thinkers. This is where you, our viewers, play an essential role. Your engagement, your thoughts, and your perspectives enrich this journey of exploration. Your likes are not just a token of appreciation for our work, but a testament to the shared curiosity that binds us all. So if you learned something new today, if this exploration stoked the fires of your curiosity, we encourage you to like this video. Your comments are not just feedback but contributions to a global conversation. Share your thoughts, your theories, your beliefs, and let's delve deeper into these mysteries together. Your subscription to our channel is your ticket to this shared journey of discovery. So, don't forget to subscribe and press that bell icon to stay updated with our latest explorations. And finally, your shares spread this knowledge, this curiosity, this dialogue beyond our community, reaching friends and families, sparking conversations, and inspiring curiosity. So go ahead, share this journey, these mysteries, these questions with your friends and families. Let's expand this community of thinkers. Let's delve deeper into the enigma of existence together.